Hello students, in this lecture we will talk about Picard's method. It is a single step method and in this we have to find out the approximate solution of y at a particular value of x. So let us consider the initial value problem, that is the first order differential equation. dy by dx is equal to f of xy with the initial conditions y at x naught is equal to y naught. Now, when we'll solve this, I can write this IVP in this form, equation 1. On integrating both the sides of this equation, we will get this equation 2, which is the integral equation equivalent to the equation 1, which contains the unknown y under the integral sign. So here you could see in this integral sign, we have a function of x and y. But integration is with respect to x, so here the y is the unknown variable under the integral sign. How would we find out the approximations? So the first approximation, y1, is obtained when we put y is equal to y naught in this function. So y naught is given to us, that is the initial condition, that at x naught, what is the value of y? That is y naught. So just substitute y as y naught on the right hand side under this integral sign and we will get the first approximation, that is y1x. Similarly, for the second approximation, in the same equation number 2, we will put y as y1, the first approximation, and we will get the second approximation. And this process is repeated until the desired level of accuracy is achieved. So the main crux of this method is कि as it is a one-step method, so what you have to do, remember, one data point is used to find out the next approximation of the y. So here we are using y naught to find out y1, and for y2 second approximation we are using y1. Now this is our general formula. As it is very easy, but it has certain drawbacks. It is not useful for computer-based solution, and it is not always easy to find out the value of the integral. Now, we have some certain questions. So here I have written it. Solve dy by dx is equal to 1 plus xy with the initial condition x naught is 0 and y naught is 0 up to third approximation. So we have to find out the solution up to third approximation. Now, consider your function f of xy as 1 plus xy and x naught is 0, the initial point, and at this particular point the value of y naught is also 0. First approximation is given by when you put in this formula n is equal to 1. So left hand side पे जब आप n को 1 put करेंगे तो आपके पास आएगा y1x. Right hand side पे y naught will remain same. Under the integral sign we have f of x comma y naught. अब आपके पास फंक्शन है 1 plus xy, तो वहां पे y की जगह आपको y naught सब्सटीट्यूट करना है. इस क्वेश्चन में y naught की वैल्यू 0 है, तो ऑटोमेटिकली आपका ये जो फंक्शन है दैट इज कमिंग आउट टू बी 1. So in this you have to just integrate 1 dx. So integral of 1 is nothing but x. आप लिमिट अप्लाई करेंगे, आपके पास y1x की वैल्यू आएगी, दैट इज x. नाउ वी मूव अहेड टू द सेकेंड अप्रोक्सीमेशन. सो इस फॉर्मूले में जब आप n को 2 पुट करेंगे तो आपके पास सेकेंड अप्रोक्सीमेशन आएगा. वील बी यूजिंग y1 इन दिस केस. सो एज यू कुड सी अंडर द इंटीग्रल साइन आपको f of x y1 कैलकुलेट करना है, विच इज 1 plus x टाइम्स y1. सो y1 हम ऊपर ऑलरेडी कैलकुलेट कर चुके हैं, x की वैल्यू हम यहाँ पे पुट करेंगे y1 के प्लेस में. सो हमारे पास जो f of x y1 है दैट इज द फंक्शन ऑफ x एंड y1 इज कमिंग आउट टू बी 1 plus x स्क्वायर. आप इंटीग्रल साइन में वो सब्सटीट्यूट करेंगे, लिमिट अप्लाई करेंगे, तो आपके पास अल्टीमेटली y2x की वैल्यू आ रही है x plus x cube by 3. थर्ड अप्रोक्सीमेशन जब आप n को 3 सब्सटीट्यूट करेंगे सेम फॉर्मूले में, तो हमारे पास थर्ड अप्रोक्सीमेशन आएगा एंड उसके लिए हमें कैलकुलेट करना पड़ेगा f of x, y2. f of x, y2 is 1 plus x times y2. y2 हमने सेकेंड अप्रोक्सीमेशन यूज कर रहे हैं विच इज x plus x cube by 3. Ultimately you will get this function as f of x y, 2 1 plus x square plus x raised to the power 4 by 3. जब आप इसको इंटीग्रेट करेंगे विद रिस्पेक्ट टू x तो आपके पास आएगा x प्लस एक्स क्यूब बाई 3 प्लस एक्स रेज टू द पावर 5 अपॉन 15. आप लिमिट अप्लाई करेंगे 0 to x, so this is what your third approximation is coming out to be. So like this we could calculate the 3 approximations for this particular question. This is a very easy method, but it has a drawback that it is very difficult to calculate the integral at certain point of time. Now we move ahead to the next question. It is slightly different from what we have done in the first question. In this we have y dash plus y is equal to e raised to the power x. Now what is our function here? Our function is not e raised to the power x. आपके पास यहाँ पे जो इक्वेशन गिवन है दैट इज y dash plus y is equal to e raised to the power x. What is IVP? IVP का जो जनरल फॉर्मूला है दैट इज ऑलवेज dy by dx, दैट इज y dash also, and this is equal to a function of x and y. So this is equal to function of x comma y. यहाँ पे जो हमारे पास इक्वेशन है लेफ्ट हैंड साइड पे y dash तो है दैट इज dy by dx प्लस y भी है. सो हम e raised to the power x को अभी अपना फंक्शन एज्यूम नहीं कर सकते, पहले हम उसको सॉल्व करेंगे. सिर्फ y dash लेफ्ट हैंड साइड पे रहेगा, बाकी जितने भी आपके पास टर्म्स है वो सब राइट हैंड साइड पे आएंगी. सो अल्टीमेटली वी गेट y dash is equal to e raised to the power x minus y and this is our function. y नॉट आपको यहाँ पे 0 गिवन है, x नॉट आपको 0 गिवन है, and we have to find up till fourth approximation. That means आपको यहाँ पे n की वैल्यू 1, 2, 3, 4 पुट करनी है और तभी आपको y4 approximations मिलेंगे. So how to calculate y1? सिंपल इजी स्टेप्स जैसे हमने ऊपर वाले क्वेश्चन में किया था. n को जब 1 पुट करेंगे तो आपके पास यहाँ पे y नॉट प्लस 0 to x function of f of x comma y naught. I've already calculated this and I am getting the function as e raised to the power x. When we'll solve it, we put the limits, so we'll get the final answer as e raised to the power x minus 1. On the similar basis, we can calculate y2, y3 and ultimately y4. So this is what I'll get the answer. y2x is coming out to be x, y3x is coming out to be e raised to the power x minus x square by 2 minus 1, and y4x is coming out to be x plus x cube by 6. So these are my 4 approximations, and this is the Picard's method. In the next lecture, we'll be talking more about Picard's method. There is one more example that could come in the exam, so we'll be talking about it. Thank you so much.